Well, I was looking at these transistors in here, just testing all the transistors in the circuit really. That's the first things I do. It clearly looks like it's been recapped, so it's not I shouldn't think it's a capacitor problem. They've been recapped with Rubicons. They look good quality capacitors. I'm not sure how old they are, but they're not original, and everything looked okay. I was going through all this stage here. This is all the sort of like the voltage state and the bias controlling stage here. This is the voltage amplifying section. We've got a common tail pair here somewhere if you look through. We go into the sort of like the push-pull stage here, the first stage of the push-pull. These are our output FETs here, and they're basically in parallel with these emitter followers or gate followers or source followers, whatever they are. They're basically in series to prevent the resistors. I think to make them share basically. I'm not sure if they're emitter follower resistors. That tends to be used more in a bipolar, you know, a normal transistor amplifier rather than field effect transistor. So these are the drivers. These are the two drivers that we saw on the circuit board, like the ones that look like TO220, like a modified TO220 package. And so they were our main output transistors on the heatsink there. They're the two power transistors on the circuit board. Now this transistor, when I was testing it, I compared it with the other channel. That's basically what you do with a stereo amplifier, you compare it. Now this transistor didn't measure the same. So I took the transistor out and checked it, and yeah, it looks okay. Went to put it back in, and all the leg orientation looked wrong. So I sort of like looked at the other how it came out, put it back in again, and then compared it with the other board, and it looked like the transistor was in the wrong way. Put the transistor in the correct way, and now the waveform appears to work correctly. It looks like we've got our proper push-pull stage back and working. I don't know if someone took this transistor out before to check it, but well, obviously it's been out because it must have worked when it left the factory. Anyway, put this transistor back in, and it all appears to have a good output stage. So the next thing to do, I suppose, is to box it all back up, put the heatsink guards back in, run it up, and see what sort of output it makes. Okay, let's put the cover back on this amplifier. Let's give it a run just to see how it's performing. So we're going to look at the left-hand channel first. I'm feeding a 1 kilohertz, 500 millivolts input to the auxiliary input of the Sony amplifier. The output of the amplifier is connected to the dummy load, and the dummy load is set at 8 ohms, and we're measuring the output from the dummy load through the scope and the output section of the audio analyzer. So what I'm going to do first is run it up to just before clipping, and we'll have a look at the waveform on the scope. That's what we're going to look at first. Make sure it's clipping symmetrical, make sure there's no of that horrible distortion we had before. It looks like it simply was that someone put the transistor in the wrong way. I can't see anything else wrong with it. There's no damaged components. I went through all the components, they all look fine. So that's good, because these parts of these FET amplifiers are very rare, if nigh impossible to find. So let's start by looking at the left-hand channel. I'm going to run it briefly up into clipping, check for symmetrical clipping and nothing horrible happening, and then we're only going to run it for a couple of seconds, and then we'll back it back down again. And you'll see it's just trembling on the top and bottom of the waveform. We're just running into clipping there. Nice powerful output signal, no problem at all. Let's look at the right-hand channel. Same thing. Perfect, nice clean signal, no problem at all. You can see that there's no distortion on that waveform. That's good sign straight away. So the next thing to do is we'll have a look at the output on the have a look at the audio analyzer and see what we're getting. So let's go to a distortion, which it was on distortion, I think anyway. So we'll look on the left-hand channel, and we'll drive this. Should we drive it to a couple of increments so we do the same level both sides? About there. Distortion 0.053% on the left, that's good. And on the right, up there, 0.053%. Distortion is good, it's in spec, that's no problem at all there. I know everyone wants to know how much power does it make? How much power does it make? Okay, so we'll do both channels driven to 8 ohms. Just before clipping, we'll see what we get. So we'll enter our parameter for measuring power. So it's 19.0808 specifies the impedance of the load you want to measure. special function. Right hand meter will now display watts. So we just run it back up to clipping and just come off clipping so it's not, there we go, 77 watts. And it's going to be the same roughly, around 77 watts. We call it, I mean 75 watts probably, with about 1% distortion. Yeah, that's 75 watts, so that's good. I mean, it's pretty highly spec amplifier for its day. I'm not going to try 4 ohms. It's too stressful on this poor old girl. She doesn't want to be driving 4 ohms sinusoidal into clipping really at her age. So that appears to be working really well. That's no problem at all with that. Now I think what I will do is I'll do a frequency response, or not frequency response, a distortion plot with the Pete Millet software, and we'll see what we get. So I'm going to set that up, run a sweep, and see what distortion we get on the sweep. Right, that's a frequency response plot I've just done. Did about 5-10 watts, something like that. It was pretty low power, said it wasn't anywhere near clipping, so it wasn't very low level. Yeah, that's our frequency response. We've got a nice sort of standard roll-off you'd expect from an amplifier. It's got a little bit of a tiny little bit of boost, but bear in mind this is 0.2 dB steps, so this is really flat as a pancake. And you might be even taking into account the leads and things like that. So the amplifier's got it looks like it's got a very slight roll off into the subsonic. Here's 20 Hertz. It's starting to roll off 0.2 dB, but I class that as a flat response all the way through. 10 kilohertz is about 20 kilohertz there, and it's plus less than 0.1 dB. So frequency response, the amplifier is superb, very flat. Distortion level's good. Nice little amplifier, and these things are collecting silly money now. I've been looking, I was thinking, oh, I wouldn't mind one of these amplifiers. Might go and have a look, see how much they are, and had a look on eBay, and for some reason these V-FET amplifiers have got a bit of a fad, a bit of a craze on. There's people saying, oh, they sound fantastic. I listened to this amplifier a couple of nights ago. I described the sound with my aging hearing as pretty average really, not particularly detailed from what I could tell. A nice sounding amplifier. Did it sound like a valve amplifier? Not really. It just sounds like one of the sort of like 70s 80s amplifiers that've got that slightly warmer, slight lacking in detail maybe, but pretty nice. I don't think it's as good as the Marantz 1060 even, to be honest with you. But a very interesting amplifier, one that I've really enjoyed working on. I just hope that the person who owns it is either going to sell it to someone who really enjoys it and is going to look after it, or keeps it for himself. And I think it's probably a bit of a sort of like a milestone in hi-fi history. Maybe these V-FET amplifiers. Certainly an interesting design. A bit fickle to work on. A bit fragile now, but anyway, I hope you enjoyed this. Thanks for watching, and some more to come.